Hi guys, my name is Taylor, and today I'm going to teach you about two very similar reactions that can be used to make heterocyclic compounds called isoquinolines. Our first reaction is the Bischler-Napieralski reaction, in which we start with an acylated phenylethylamine reacted with a dehydrating agent such as P2O5, PPA, or PLCl3 to get our desired isoquinoline. The mechanism is rather straightforward and starts with the electrons on the oxygen attacking the dehydrating agent. From here, we can make a resonance structure in which we move the plus charge from the oxygen to the more favorable nitrogen position. After this, we can use the electrons on the oxygen of the dehydrating agent to force off one of the chlorines. This will remove the negative charge altogether. After that, we have an EAS step in which one of the double bonds on the benzene ring attacks the double bond to the nitrogen. We're removing the positive charge in the nitrogen, but creating a carbocation at the bottom of the once aromatic ring. After this, we can deprotonate to restore the aromatic ring, as well as have a proton transfer occur between the oxygen and the hydrogen bonded to the nitrogen. The electrons that were once in between the nitrogen-hydrogen bond can swing down to form a double bond and force off the oxygen dehydrating agent complex. This would give us our desired isoquinoline. Our next reaction is the Pictet-Spengler reaction. In this case, we start with a phenylethylamine reacted with any carbonyl compound in acidic conditions to give our desired isoquinoline. The mechanism is very similar, except it starts with electrons on the nitrogen attacking the carbonyl. From there, we can have a proton transfer occur between the oxygen and one of the hydrogens bonded to the nitrogen. Because we're in acidic conditions, we can have the electrons on the oxygen grab an H+ to make water. As we know, water likes to leave, so we can have the electrons on the nitrogen form a double bond and force off the water. In this reaction, we also have a similar EAS step in which the double bond of the benzene ring attacks the double bond to the nitrogen. This creates a carbocation at the top of the once aromatic ring. Here we can deprotonate to reform the aromatic ring and create our desired isoquinoline. Now these reactions, though they looked rather similar, can you guys spot the difference? One of the main differences is our starting materials. In the Bischler-Napieralski reaction, we're starting with an acylated compound, where in the Pictet-Spengler reaction, we're starting with just a regular phenylethylamine. Another difference is in the reagents. In one reaction, we're using dehydrating agents, where in the other, we have to have a carbonyl as a reagent as well as acidic conditions. The final difference is found in the products. In the Bischler-Napieralski reaction, we have a dihydrated isoquinoline, where in the Pictet-Spengler reaction, we have a tetrahydrated isoquinoline. Now, as we know, the best way to learn organic chemistry is through practice problems. So I have made these wonderful problems for you all to try. So feel free to pause the video and test them out. And if you guys are curious about my answers, I also made those, so here they are. But yeah, that's all I have for today. Those were my two name reactions, and I really hope you all enjoyed the video.